Hello everyone, if you don't like shapes, you should triangles. That is what we are doing today, similarity with triangles. We are going to be showing that two triangles are similar or are not similar. That is the purpose of this. Because your teacher is asking you to learn it. In the real world, you don't really try to prove things are similar. You tend to just use similar triangles to find measurements. But, that's real life, and here we are in a geometry class. So we're just going to roll with it and go over these three different types of triangle similarity theorems. The first of which is called angle-angle similarity. The A's always stand for angle, and the S's always stand for side. And what happens is if two corresponding angles are congruent, then the triangles have to be similar. So if you watched my last video, one of the things we said was that corresponding angles are congruent. So by definition, in a similar figure, the angles have to be the same. And what this is saying is that if you know two of them are the same, then they are definitely going to be similar, which makes sense if you think about it for a bit. If this is 75 and that's 75, this is 31 and that's 31, then that means all of the angles have to be the same. So the question is, well, why? Why do these two angles have to be the same? And the answer lies in the fact that all angles in a triangle add up to 180. Like every single triangle. You should have learned that by now, but just in case not, in every triangle, the angles add up to 180. So if these are the same and these are the same, then it has to be that those are the same, which is why you only need to know two angles. And with that said, when you match all the angles together, it doesn't matter how big the sides are, they'll always be in proportion, which makes them similar. So this right here would have angle-angle similarity. You have two angles. In the second one, you're supposed to look for two pairs of angles, in which case we have one right there. Yay. But it doesn't immediately tell you another pair of congruent angles. You have to use some other tips that we've done. In this case, it's something called vertical angles, which is these two things right here. It says that whenever you have this X shape kind of going on, the angles across from each other will always be equal. Their measures will be equal. So you actually do know that these two angles are the same. So you do have angle-angle similarity. Like so. I forgot. It says, if yes, write a similarity statement. Okay, so in the similarity statement, you can see that A and D match, C and F match, and then B and E match. So AD, what I'm going to do is I'm going to draw a triangle. And there's a couple of ways to do this. One way is you can do ABC, just ABC is similar to triangle, and then you match them. ABC would go D, E, F, right? D, E, F. If it's a bit difficult for you to imagine like that, you can always cheat a little bit and do it vertically instead. Triangle, oops, it's a triangle. ABC is similar, and then just do it this way. I see A and I see D. So you can literally put the A and D on top of each other. A matches with D. When you look for B, B is up here and I squared it. The other one that's squared is E. So B and E go together. So I'll put them physically on top of each other. And then C is the blue circle and F was the blue circle. So F has to be with the C. And you just line it up vertically. Either way, we got D, E, F, def. So you get the same thing. It's just, which way do you like to do it, whatever. Here, triangle, let's go with V. V is being matched with Y. It looks like X is being matched to itself, right? X right here and X right here. And then W and Z are the only ones that are left. So there you go. That'd be your similarity statement. All right, over here is the next one, side, side, side similarity. If all corresponding sides are proportional, then the triangles are similar. So it's saying that if you know all three sides are proportional, then automatically all the angles are going to be congruent, matching, so you don't have to check them. It's enough to know that all three sides are the same. It's very similar to the congruence ones. If you remember, we had a whole bunch of congruence statements like side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse leg, I think were all of them. It's very similar to that, where side, side, side was enough to show that they were congruent triangles. Now we're saying that if all three sides are proportional, then it makes them similar. So determine if they are side, 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 which means this is a yes, no. It could be no. You need to see if they are proportional. And my big trick that I do is I take the numbers in each triangle and I order them from smallest to greatest. Because sometimes it's obvious which sides go to which sides. Like if you're visual, you can just see it's like boop, boo-doo, boo-doo. Those ones go together, those go together, and those go together. But it's not always obvious. Kind of like this. This one, it's not obvious to say what goes to what. So what I do is I go from smallest number to biggest number. So what's the smallest number? 3. So I would write down to 3, and then I'd leave some space. The next number is 4, and then 5. And then underneath of it, I would do the bigger triangle, because these are all going to be fractions. Remember, proportions, fractions. The smallest number here is 6, then 8, then 10. And what you do is you see if they are equal to each other. So, are they equal to each other? Well, in this case, yes. 3 over 6 is 1/2. 4 over 8 is 1/2. And 5 over 10 is also 1/2. Now, if you feel like using a calculator on these, that's fine, I guess. You know, you can always double check 3 over 6, 3 over 6, 4 over 8, 5 over 10. You can see that they are all 0.5. So they are equal, so the answer is yes. They have side, side, side similarity. Down here, same thing. I suggest pausing and trying it. Once again, just make sure you're listing from smallest to greatest. So here, the smallest is 30, and then 32, and then 35. Over here, the smallest is 24, then 25, and then 28. And we'll see if they're the same. 30 over 24, 32 over 25, 35 over 28. So the question is, are they all the same? The answer, no. This one is an 8, not a 5. They are not all the same, so these are not similar. Not similar. And that's it. That's it. Check all the sides are proportional. And they were not. 2 of them were, but not all 3. So no go. The last one is kind of doing both. You have to check if the angle is congruent and the sides are proportional, but it is side angle side similarity. If 2 corresponding angles are proportional and the included angles are congruent. So like here, I have my 8 and 20, it looks like, and also the included angle. It's the angle between them, right? Just like the 6 and the 15, it gives you the angle between them. It does have to be the angle between them. If it gave you one of the ones on the sides, you couldn't do anything. It has to be the angle between them for side angle side. That's why the A is literally between the two S's. It's to show that it has to be there. If the angle was on the side, then it wouldn't work. So same thing as before though. The smallest number is 8, and then comes the 20. So I'll list them smallest to biggest. And here the smallest is 6, and then the 15. So you still set it up, and you just see if it is true. From the previous video, if you felt like cross multiplying, you could. Just in case you had that feeling of doing it. You won't get the wrong answer, you'll get the correct answer. But you could just do 8 over 6, 20 over 15. And they are the same. If you have no idea what I'm talking about with cross multiplying, then I'm saying that that times that should be equal to this times that. Which you'll see they are if I tried it just for, because why not, purposes. You can see they're the same. So cross multiplying also works to check to see if they're the same. But the big thing is that they should be exactly the same whenever you do stuff. So the answer is yes again. And I guess that would be triangle K goes to N, J goes to M, and L goes to P. Like so. Once again, always free to pause, rewind as many times as you want. Hopefully until that makes sense. Number 6 is a lot more interesting because you have a triangle inside of a triangle. And it's like, well, do you have an angle, the included angle? Because it does say that you need the included angle, but there's no angle shown. But the thing is, if you look at the two triangles, I'll make a red triangle and a yellow triangle, which is looking greenish because of the black ink, but whatever. If you look at it, you can see that they actually do have an angle that has to be congruent to the other one, because this red triangle has this angle and the yellow triangle also has this. So they share this angle in common, which means angle A is congruent to itself. They do have that. I don't know if you watched other videos, but sometimes they'll say if two triangles share a side to mark it congruent to itself. Well, if two triangles share an angle, you should mark it congruent to itself. So you do have side, angle, side. So remember, for side, angle, side, you have to check if the angles are congruent, and I just said yes, they're definitely congruent. Then you have to check to see if the sides are proportional. You do have to be very careful, though, in problems like this. I'll do an example in a second. But you have to make sure that the numbers are going to the correct things. Like, if you look at the red triangle, the lengths we know in the red triangle are 12 and 15. And then if you look at the yellow triangle, it looks like this length is 21, and this length is 25. Like so. And you would check to see if that is true. Once again, I recommend pausing and seeing if you can do it. Because it's one thing to watch, it's another to do. It looks like the answer is no. These are not in proportion, so they're not similar. Okay, so what I was getting at earlier, let's see if I can find the question. Here's one. Boop. Number 6 on this sheet. Take a look. It almost looks the same, right? I mean, we have this triangle inside of a triangle, right? It looks pretty similar, right? So you'd think, well, you're going to do something similar. And the answer is, well, not really. Maybe start out the same way, but you definitely don't end the same way. You could definitely still see there's a triangle inside of a triangle. So we'll go ahead and mark this angle. And you could look at this small triangle right here. And you could say, well, of the three sides, we know 16 and 25. 16 being the smallest. So 16 and 25. And then you say, well, that has to match the other sides. So this is 88, and this is the trick. The thing is, it does not tell you how big KM is. If you think it does, then you are wrong. I am sorry. 107 is not going to be used at all in our proportion. We know that this whole thing is 88. That is good, right? That is something we want. This entire triangle side is 88. We're good with that. But we need to know this entire triangle side. It does not tell us that. It says that this is 25 and this is 107, but it does not tell us this whole part, just to try to do what the heck they did, you know. This part they don't tell you. You have to add them together, 25 and 107, to get 132. So the whole side is 132. So when we do our proportion, we know 88 and we know 132. We know 88 and 132. Once again, smallest number first. Smallest number first. And now we can check the proportion. But notice the difference. You have to make sure it's the entire side of a triangle. You can't just use the 107. You have to add it to find the entire length. That's the trickiest it's going to get, most likely. So I'll check it. 16 over 88. 25 over 132. And it looks like no, they're not similar. It would have been side angle side if it was, but it wasn't, you know. And there you go. All right, the video is getting kind of long, so I'm just going to say one more thing because, you know, I work with students, and one of the big things that I've been seeing with people is, you know, state if they're similar or not, but also state how you know. Because remember, there are three options. I'll do it on the back of this. There are three options. I'll do it on the back of this one, actually. Angle, angle, side, 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 and angle, side, angle. So remember, angle, angle is when you have only angles. If you only have angles, then check to see if they are the same. That is what you do. If you see a triangle and they do not give any sides, right? Only angles, no sides. If no sides are marked, then check the angles, see if they're the same. If they are the same, it's angle, angle. Come on, adjust. There we go. Side, side, side. You only have sides. Only sides, meaning no angles. Once again, those have to be in proportion. Proportional. Proportional. There we go. It's where you have a fraction equals a fraction, right? A fraction equals a fraction. But because, you know, there's three sides, it's actually going to be three things. And I don't have a third color on me right now, so I'll just go back to this one. Boom, boom. Proportional. All three sides have to be proportional. Angle, side, angle. I don't know why I wrote that. It's totally side, angle, side. That is when you have two sides and an angle, or both sides and angles. Then you have to do both. The angles have to be equal. Angles equal. Sides proportional. both of them. So hopefully this helps. If you want to take a picture of it to save for later, you can. But that is what you need to do. Decide which of these you have to be. If you have sides, you need to make sure they're proportional. Don't just say, yes, this is side, side, side because we have 3 sides. That is not correct. If you have sides and angles, don't just say side, angle, side because that's what you see. You have to check that they are proportional. You have to check that the angles are equal. Okay, I'm running a bit long, so have a good one. Hopes this helps. Here's the notes again if you need to see them. Bye-bye.